We've invented a device that can take water from humid air and sunlight and convert it into hydrogen, which can be used as a fuel or a chemical feedstock for a future energy system based fully on renewable energy. Our technology has been enabled by this, a transparent, porous, conductive substrate, which for the first time allows a semiconductor to be coated and have a large surface area to interact with the humid air. This is really important because there's really a lot of sunlight available, but the sun doesn't shine all of the time. So we need a way to store the sunlight for future use. And using sunlight to split water into hydrogen and oxygen, storing the sunlight in the form of hydrogen, is a leading method to do this. Our work was inspired by the way a leaf works. Natural photosynthesis occurs by taking carbon dioxide from the air together with sunlight and produces sugar, effectively storing the sun's light in a chemical form.
So in our lab we have a lot of experience with a semiconductor, but usually we coat them onto a flat surface. Here we have a three-dimensional network. So that was a challenge to find the appropriate method to coat this semiconductor material on this new template. So to develop our photocathode electrode for hydrogen production, first of all we took some quartz fibers that we blended in order to homogenize the fiber length.
We filter them and compress them into a wafer.
We make a quartz fiber template by heating the fibers at 1350 degrees to melt the fibers and connect them together in a network. And then the second step is to make this transparent porous support conductive by coating a conductive layer, which is also transparent on the top.
Now the challenges here are to find a system that has the right porosity, the right mechanical properties, and sufficient transparency and conductivity to enable this gas phase photoelectrochemical reaction. Coating that with a light-absorbing semiconductor material gives us our final photoelectrode that, together with a catalyst and integrated with a membrane in a photoelectrode membrane cell, can make an overall solar to hydrogen production device in the gas phase. This has been previously shown by our groups and others in the liquid phase using liquid water, but it's not very practical to imagine a liquid-based solar cell on the roofs of our houses. Instead, we can imagine using the humidity from the air in the gas phase and splitting that into hydrogen, but that hasn't yet been possible to date because current technology is using gas diffusion electrodes that are opaque. This one's made from carbon-based material. It absorbs the sunlight and prevents our semiconductor material from absorbing the sunlight and performing the reaction. So our work has been to develop a transparent and porous conductive substrate which can allow us to coat it with the semiconductor material, giving it the ability to absorb the light and convert the water into hydrogen in the gas phase. Our initial demonstration of the proof of concept of this device is only a first stage. The overall solar to hydrogen efficiency is still quite low, but our invention of the transparent, porous, and conductive substrate now opens the door to advance this technology further. So our next step are going to be to optimize the pore size, optimize the thickness, and optimize the mechanical properties, as well as investigating the coating of different semiconductors and different catalysts to improve the solar to hydrogen conversion efficiency of this type of device. In the future, if we're successful to find a system with a high enough solar to hydrogen conversion efficiency and good enough stability, we can imagine these artificial leaf-based systems both in arid environments like the desert where there's not a lot of liquid water, but also in more humid environments like the Lake Geneva region.
Civil engineering impacts on all areas of our lives, from the roads and bridges we travel on to the buildings we live and work in. These are all made possible by the innovation, planning and expertise of civil engineers working hard to improve our lives. For more than 200 years, members of the Institution of Civil Engineers, or ICE as it's known, have been responsible for some of the world's most recognisable structures and landmarks, including the Statue of Liberty, the Panama Canal and the Channel Tunnel, and such present-day projects as Crossrail. Having worked together previously on a highly successful series of books, ICE and St James's House, an international leader in publishing, media and communications, are now looking to the future of urban living and the importance of smart cities, with their latest collaboration putting the smart into cities. This exciting new project, which incorporates in-depth documentary, a dynamic digital platform and an extensive global campaign, will provide unparalleled insight into the major sectors and commercial spheres that engage with the world of engineering, shedding light on their activities, success stories and long-term objectives. A dedicated online hub located within the ICE's main website will host all the campaign's films, interviews, news, social media and other up-to-the-minute content. It will be accessible to each of the ICE's more than 92,000 members across 100 countries, as well as to associated bodies and industry institutions worldwide, resulting in an anticipated global audience that will run into the millions. With more than 1.5 million people around the world moving to urban areas every week, the work of civil engineers and the industry's aligned sectors isn't just important, it is essential to the sustainable development of our cities and built environments for generations to come. Presented by ICE and St James's House, Putting the Smart into Cities will be at the very forefront of the ideas that are driving this vital development.
We believe a better tomorrow means all people have safe, comfortable spaces to live, learn, work, and play. That fresh, clean air is the standard, both indoors and out, and that everyone has access to healthy food and medicine, no matter where they live. At Trane Technologies, we have clear purpose: to boldly challenge what's possible for a sustainable world. As a global climate innovator, we work every day for the bright future we all envision. We've made a pledge to enable opportunity for all, to reduce our customers' emissions by 1 gigaton, and to lead by example with carbon neutral operations. With our 2030 commitments, we've set the pace for positive change in our industry, change that can have a transformative impact on our planet and for future generations. Those commitments are made possible by the people in our company. People who uplift each other and dare to do things differently. Teams who innovate to create technology that is good for our customers and better for the world. Our impact extends into our communities, where we help build the next generation of leaders and visionaries by ensuring people of all backgrounds can succeed. We know the bold actions we take today will create a better, stronger world tomorrow. We are Trane Technologies, and we invite you to join us in challenging what's possible.
Energy is the foundation upon which modern society exists and develops. How to use Earth's limited resources wisely, efficiently, and scientifically is a question faced by all mankind. The beautiful Southeast Asia shines brightly like a sapphire. Our RTU products are improving power consumption quality for local people in terms of household and industrial usage. Being one of the fastest growing countries in the world, India is troubled by problems with relatively backward power grid construction. We have participated in India's National Power Distribution Network Restructuring Plan, 12 Plan, or APDRP, and our products have entered 6 states and 25 cities, with power grid quality substantially improved and power cuts and power loss greatly reduced. Today, economic globalization offers us more opportunities. China is taking the lead to revive Silk Roads, and the One Belt, One Road initiative has enjoyed wide support from international community. The vast African continent is the cradle of human civilization. In response to national strategy, we continue to strengthen management of African power grid services with a goal to bring light to each and every corner of African continent. For example, we built for Equatorial Guinea the most advanced grid dispatch center in Central Africa, which is responsible for national grid O&M management. Automated power distribution system solutions are offering enhanced operation efficiency for Zambia's power distribution network, as well as reliable power supply services. In the future, we will continuously be committed to sharing technologies and experience in energy sector with more countries to demonstrate the strength of China and benefit the whole world.
On 2017 year, Global Chinese Power Energy Society was officially registered and established in Hong Kong after strict scrutiny by the government of Hong Kong Special Administrative Region. Now GSPEACE is a member of the World Federation of Engineering Organizations. Asia Pacific Research Institute of Smart Grid and Renewable Energy is affiliated organization of GSPEACE. Hao Yongchen, who is the current president of GSPEACE and also a professor of South China University of Technology, is quite pleased and proud to see a series of major breakthroughs in the electrical power technology and industry of China. In recent years, Chen and his team have carried out numerous studies and technological innovations in this regard. GSPEACE aims to provide a communication platform for Chinese scientists all over the world. These Chinese scientists come from a similar cultural background, and GSPEACE is able to enhance the connection and communication between them by organizing academic conferences and publishing academic works. Thanks to GSPEACE, overseas Chinese professionals who care about the development of China can keep up with the latest news from GSPEACE. Also, relevant professionals in China as mainland can seek overseas cooperation on this platform. A complex and ever-changing international environment has posed challenges to the people working in the electrical power industry. GSPEACE is always mindful of the responsibility and mission on its shoulders and is relentlessly pursuing the pinnacle of scientific success. International cooperation is an important accelerator to promote scientific and technological innovation and industrial application. Response to global climate change is a huge system engineering. It faces severe challenges and also contains opportunities for green development. It requires comprehensive technological innovation, system integration, and more and better solutions for energy transformation. GSPEACE calls on colleagues to go hand in hand to seek health, greenness, and peace in an uncertain world.